Hi everyone, my name is Chris Helm, and this week we are covering sense-driven AI, polling stations, broadcasting, and narrowcasting. So we're just going to jump right in here. Before I demonstrate the project, I'll give you guys a brief rundown of what it is and how it works. So what I have here is I have a game. I have my game world. It's a big field that's fenced in. And we have it populated with a bunch of bees. There are three types of bees. There are scouts, there are workers, and there are soldiers. Now, these bees, the AI in this game, it doesn't use traditional finite state machines with built-in transitions. Rather, for the most part, with a couple of exceptions, all of the AI's behavior is governed by what they can sense, by what they can see, what they touch, and what they hear. So the three types of bees, we'll start off with the scouts. The scout's sole job is to wander around the field looking for flowers, and then when it finds flowers, it reports those back to the hive. The hive is set up as a polling station so that all information that the bees receive, it comes through it passes through the hive for the most part. Moving on to the worker bees. The worker bees, they don't do anything. At first, they don't do anything until either the hive tells them that flower locations are available, or if it sees a flower, it will do something. So they start off doing nothing. If they see a flower, they'll gather it and go back to the hive and try to get a new flower location. And then once new flower locations are available, they will try and go gather a flower and then return to the hive to get a new flower location. If at any point in time the hive runs out of flower locations, the workers will just sit there idle until one of the scouts return and reports new flower locations to them. Last, we have the soldiers. The soldiers, the only thing they do is they patrol an area around the hive, and if they detect the player, or the hive notifies them that the player's been detected, they will try and chase the player down to kill him or her. Now, all of these behaviors, for the most part, are governed solely by what the bees can see, feel, and hear, and by what the hive tells them. So I'll go ahead and press play here and show you this in action. You notice that this first bee that I've highlighted, it's not going to do anything because it can't see a flower. These two worker bees right here, they saw flowers right at the get-go, so they gathered them and returned them to the hive, and by the time they did that, a scout had showed up to report new information. As soon as the scout gave out new reported flowers, the hive sent out a message to all of the worker bees that were idle that new flower locations were available, and then they go to work. So in order for the bees to operate off of their senses, all the objects that they interact with in the game world, they have to send off sense signals. So these flowers that you can see right here, they send off a vision signal every frame, and they send off a touch signal that the bees can respond to. The player sends off a vision signal every frame, and if the player runs into a bee, it'll send off a touch signal, and while it's moving, it'll send off sound signals on a periodic basis. So to show you how this works, we can select the player. So if we drag the player into the line of sight of, say, this worker bee right here, the worker bee saw the player, and then it notified the hive that the player was spotted. The hive then notified the soldiers that the player was spotted, and the soldiers are now going to try to chase the player down. And if they lose track of the player, drag the player over here. If they lose track of the player, they will go back to patrolling. So if we come over here, I can show you the sound. Now the player can gather flowers. As you can see there. And whenever you gather a flower, you store it in your inventory. Okay, now I have 2 bees chasing me. So we're going to hit the panic button, and that makes all of the bees, when you hit the panic button, all of the bees pick a point a long ways away from the player. And they go there and they cower in fear for, I have it set to 10 seconds right now. The other thing is that if we push the shift button, it will decrease the intensity of the vision and sound signals that are sent off. So it makes it harder for the bees to detect you. And I had wanted to include some sort of a visual cue that was the case, but this isn't my character model that I'm using right here. And I don't have a way to easily modify the any of the character's appearance settings. So that soldier bee just caught up with the player, and once the bee touched the player, it killed it. So now that you guys have seen how the project works, how the game works when it's running, we can come over here to the code, and I can walk you through that. So before we can talk about the AI, we have to talk about the Sense Manager. This is the bread and butter. This is what allows allows you to develop sense-driven AI. So what the Sense Manager does is it maintains 2 lists. It maintains a list of sensors. Any object, any entity in the game that wants to react to senses has to register with the Sense Manager as a sensor. And then this second list is our notifications list that gets compiled so we can notify all of the sensors of what they have sensed. which is what we're doing right here. Every frame, we iterate through our notification list, and we notify every sensor of every sense event that they have detected. And then we also clear the notifications list at the end of frame, so we don't ever send out notifications more than once. So, like I mentioned, in order for in order for an AI to receive sense information, it has to register as a sensor, which is what we're doing right here. And we'll flip over here to B data so you can see that. Every B, the B data is the universal. They're the universal variables that every B is going to use. There's not a lot here because this is all sense driven. So the biggest thing that it has to maintain is the signal list. So we come back over here. It is possible for an AI to re-register as a sensor. If that's the case, it will the sensor manager will just update the existing sensor with the new values that were passed in. And if the sensor is not already registered, it will go ahead and add it to the sensor list. And then this right here allows us to deregister any sensor. It's not used in this particular project, but if we were to expand this so that you could kill the bees or something along those lines, this would come into play. So in order for the bees to receive sense information, any object that the bees might interact with has to send off signals. We process 3 types of signals. We have vision, we have sound, and we have touch. So we'll start off with touch and work our way back up as touch is the simplest. And we'll flip over here to the flowers. All touch signals are processed using the on-collision enter and, where applicable, the on-collision stay functions. Now we could pass this information, the sense information, directly to the game object, since we have access to the game object that collided with the flower, or the player also sends off touch signals, and the hive does as well. So we could do that, but we send touch information through the sense manager, so all of the sense events are only coming from one source. So if we come back over here to the sense manager, when we register a touch signal, we pass in the case of the flower, we're going to pass in the actual flower, and then we're going to pass in the object that is touching it. It doesn't matter if the object is registered with the sensor information or not. What we're going to do is we're going to iterate through the sensor list, and if this game object is registered as a sensor, then we will compile a notification and add it to the notifications list. Now, when we go to process sound information, sound is a little bit more complex, because the sound intensity decreases the further it gets away from the point of origin. So the first thing is every sound signal has a maximum range, and it has an initial volume. And then this attenuation value is the rate at which the intensity decreases as it moves away from the point of origin. And to calculate that, we have this calculate intensity function, which we use for both vision and for sound. And to get the actual intensity of a signal, that's equal to the intensity times the attenuation raised to the distance. So this function right here will give you the intensity of the signal after it has degraded while traveling, whatever the distance is to get to the sensor. So before we compile a sound notification, again, we iterate through all of the sensors, and if the sensor is not interested in sound events, then we skip to the next sensor. Then we calculate the distance. If the distance, we're using square distance here because square distance is faster than actual distance, which requires a square root function. So if the distance is greater than the range, we're going to skip to the next sensor. And then lastly, after we've calculated the intensity, if the intensity is less than the threshold value, we're going to skip to the next sensor. So this last test determines whether or not the sensor can actually hear the sound. If all three tests are passed, then we will compile a notification and we will add it to our notifications list. And then for vision signals are processed like sound signals. Something I want to point out about the sound real quick is we're processing sound in the same way that we're processing vision. It is possible we could, if we wanted to, process the sound signal over a period of time so that the range increases, and which will increase the number of entities that receive that sound signal, and also it will affect when those entities will receive the sound signal. However, our game world is small enough that the bees wouldn't notice a difference if we were to do it like that. So we've kept it simple for this. But just know that that it is possible to set this up so that the sound signal will increase its range over time. For vision, we are going to, again, iterate through our sensors. If it's not interested in sight, we're going to skip to the next sensor. If the signal is further away than the sensor's vision range, we're going to skip to the next sensor. Then we have two additional tests that weren't necessary for sound signals. Every sensor that's interested in vision signals has a field of view. So this test right here determines if the signal is within the AI's field of view. Excuse me, within the sensor's field of view. If it's not, we're going to skip to the next sensor. The last thing we're going to do is we're going to perform a simple raycast to determine if anything is between the sensor and the signal, and if there's something obstructing the view of the signal, then we are going to skip to the next sensor. And then we're going to perform the same, we're going to calculate the intensity just like we did with sound, and if it's lower than the visibility threshold, we skip to the next sensor. If it passes all of these tests, we compile a notification and add it to the notifications list. Now, in order to make sending notifications easy and simple, I've created this iSense notification, which is an interface. Every sensor has to implement this iSense notification, which requires that they have a definition for the AdSense event with these parameters. So the only entities that accept that are interested in sensory information are the bees right now. And so in the bee data, we've implemented the iSense notification right here, and then we've provided our definition. Now, down here in the, or up here in the register sensor, you'll note that we're passing in an iSense notification parameter. So right here, when the bee registers as a sensor, it passes in the script that contains this interface as a parameter. And what that allows us to do is down here in our sensor class, we have a data member that stores that script. So when we go to iterate through our notification list, we can directly access the AdSense event function without having to get the component that it's contained in, without having to look for the script that contains that particular function. So we're able to quickly iterate through the list and notify every sensor of all the sensory events that they have detected. So now that we've done that, we can, before I get to the AI, we have to cover the Hive. The Hive is set up as a polling station. Other than the sense information, which is managed solely by the sense manager, the Hive manages all of the other information that the bees use, that the bees need to for them to function properly. The biggest thing that it manages, we have two broadcast functions right here. We have our player spotted and our panic broadcast functions, and then we have so we can narrowcast. We're using a list right here that stores any AI that's interested in receiving, in this case, new flower notifications. The other thing that the Hive manages is a list of flower locations. So the way this works is the scouts, they go out and they look for flowers, and then they report those flowers back to the Hive. They report those flower locations back to the Hive. Worker bees, they request flower locations from the Hive, and they go out to gather those flowers. And the soldier bees don't request anything from the Hive except to be notified when the player is spotted. So for the worker bees, we have this new flower notification event that we're narrowcasting. Now, I could set this up and it would actually be more efficient, and the code would be, I shouldn't say it would be more efficient, but I'd say the code would be cleaner if I set up this new flower notification like I set up the player spotted notification and the panic notification. But just to show you how narrowcasting works in Unity, we've set it up as this list. So what happens is when a worker bee requests a new flower location, if there are no flower locations in the this flower's queue, the worker bee will do nothing until it gets a new notification. So when the scouts return with new flower locations after they've been added, if if the flower queue is empty, and now it's not, what we're going to do is we're going to cycle through this list, and any bee that's not idle, or any bee that is idle, we are going to notify them that new flower locations are available right there. Now, I'll cover the worker bee code in more detail, but if the only time the worker bee is idle is if it has gone back to the hive to request a new flower location and no flower locations are available, or at the start of the game if it doesn't see a flower, it will start off as idle, and I showed you that in the beginning. So to manage this, whenever the worker bees request a flower, the hive will pass. It will store the first flower in the queue in this temporary variable right here. And then it will remove that flower from the beginning of the list, and then it will place it at the end of the list. So this, so this, in essence, this functions as a queue. And then it will return, it will pass that information back to the worker bee. Whenever the worker bee gathers a flower, it automatically returns to the hive. It will return to the hive, and it will tell the hive which flower it gathered. And if that flower is in the queue, it will remove it from the queue, so it doesn't give out obsolete data to any other workers that are requesting information. Now down here, we have our two broadcast events. If a scout bee or a worker bee detects the player, it will notify the hive that the player was spotted. The hive will then in turn notify all of the soldiers, regardless of what they're doing, that the player was spotted, and pass them the position where the player was detected at. And then I showed you guys the panic button. If the player presses the panic button and it's off cooldown, the player, it doesn't tell the bees to panic. It tells the hive that the bees need to panic, and then the hive tells all of the bees to panic, regardless of whether or not they need to. And then in this first case, the soldiers decide on whether or not they need to respond to this event. And in the second case, all of the bees individually decide whether or not they need to respond to that. So we can go on to the one last thing before we cover the actual AI. We have the player right here. This first bit of code in the update function is responsible for picking flowers and planting flowers. But this right here is the important bit right here. If the player is pressing the left shift button in this case, stealth is set to true. And then down here, when it sends out, the player sends out a vision signal every frame. Now, if the player is stealthed, it sets intensity factor to 0.5. Otherwise, intensity factor is 1. So when it passes the vision signal and also the sound signal, it multiplies the signal intensity by this intensity factor. So if the player is holding down the stealth button, it reduces this. It reduces the intensity of the visibility and sound signals that the player registers by half. which makes it harder for the AIs to detect the player. So now that we've covered that, we can actually go over the BAI. So, as I mentioned before, the scouts, they're responsible for roaming around the level and finding flower locations, reporting those to the hive. So the way it does that is it starts off by picking a random point somewhere in the level, and then moving to that point while it's searching. While it's searching, as long as the scout is not panicking, it will parse through the signals, and when it parses the signals, what it does is it looks for obsolete signals and removes them from the signal list. That way, old signals aren't. That way, it doesn't respond to old signals. And then we're going to respond to a signal. And to do that, first we have to select a signal. So signal selection works. It chooses signal based on this order of precedence, which is touch, sound, player sided, and then anything else that's sided. So if it detects a touch signal, it's going to process that. If it detects a sound, it's going to process that. If it detects the player, if it sees the player, it's going to respond to that signal. And then if it doesn't see the player, it's going to respond to the oldest other vision sight event that's stored in the sensory input. And then down here, we have our actual respond to signal function, which is basically a complex decision tree. So if it's a touch event and it happens to be the hive and the scout is reporting, it's going to pass any flower locations it has stored to the hive. It's going to clear its flower list, and it's going to go back to searching. If it touches the player, it's going to notify the hive that the player was detected, and it's going to panic. And if it touches a flower, if the flower is not already stored in its flower list, it's going to add that flower to the flower list. If the event is a sound and it's the player, it's going to notify the hive that the player was detected. And if it sees the player, it's going to notify the hive that the player was detected. And then if it sees the flower, it's going to go through this complex bit of Boolean logic here, and if it passes all the tests, it will add the flower to the flower list. And then to ensure that we're not adding the same flower to we're not processing the same flower over and over again, we're going to update our current signal, which will prevent it from processing the same flower over and over. And then we're going to remove, regardless of the event, we are going to remove the signal from our sense event queue, so that we don't ever process the same event twice. And then down here we get to the actual finite state machine, which tells it what to do. Once it reaches its initial target position, it goes to the next one. If when it reaches its max flower count, or the search time is up, it returns to the hive to report its stuff. If it's reporting, once it finishes reporting, it goes back to searching. And then panic. I'm going to cover this right now, so I don't have to cover it for the other two scripts, because it's the same in both of those. If it's panicking, it's going to select a point that's far away from the player and it's going to move to it. And then once it's there, once it gets to that point, it's going to cower in fear for the specified amount of time. In this case, all the bees cower for 10 seconds. And then it's going to return to its previous activity. Now, the last little bit right here, this last line of code, while the scout is panicking, it does not respond to any signals. So it still receives sensory input, but it doesn't process any of that. So before we go back to whatever we were doing before it panicked, we're going to clear our list of all of the sense events. That way we can prevent bottlenecks and performance loss. And then this last function right here, this is responsible for selecting a point on in the level for it to move to while it's searching. So if we move on to the worker bee, so up here in the scout, you notice I have right here, we're registering a listener with the Hive's panic notification broadcaster. And we are doing the same thing right here in the worker bee. And then this line of code is we're registering a listener with the new flower notification broadcaster. So all worker bees, they start off idle. They don't do anything. And then as long as they're not panicking, they will parse their signals and they will respond to signals. So when it goes to respond to a signal, it uses the same selection process that the scouts did. It picks based on an order of precedence: touch, sound, player-sided, and other-sided, which is what this does. And then when we get down to the respond to signal, this again is a complex decision tree. So if the signal type is touch, if it's touching the hive and it's delivering pollen to the hive, we're going to deliver that pollen. We're going to tell the hive to remove that flower from the flower queue. And then we're going to request a new flower position. If a new flower position is available, we are going to go to that position and attempt to gather pollen. If the hive does not have any flower positions available, then the worker bee is going to sit idle until the bee either has to panic because it detects the player, or the player pressed the oh crap button, or the hive notifies the bee that new flower locations are available. If the worker bee touches the player, it's going to notify the hive that the player was detected and it's going to panic. If it touches a flower, it will gather pollen from the flower if it has not already gathered any pollen, and then it will return to the hive to deliver it to the hive. Now, if the worker bee hears the player, it will notify the hive that it heard the player and it will panic. And if it sees the player, it will notify the hive that it saw the player, and it will panic. If it sees a flower, it doesn't matter if it was the flower is at the location that the hive reported that the hive gave it or not. If it sees a flower and it's not delivering pollen to the hive and it's not panicking, it will go to that position, and it will gather pollen from that flower and then return to the hive. And that's important. If we come over here, we have a flower right here, flower number 9. I can show you an example of how this works. If a worker bee gets a flower location, and let's say that it is flower number 10. Flower number 10 is next up. The worker bee will start heading off towards this flower right here. If flower number 9 were to respawn and the worker bee sees flower 9, rather than going to flower 10 over here, it will immediately go to flower 9 and gather pollen from that and then return to the hive and request a new flower location. And there may arise situations where the flower location that the hive gives is not necessarily the closest flower, and the worker bee may see a different flower and gather pollen from it instead. So that's how that works. The hive doesn't ever tell, the worker bee doesn't ever know where any flowers are. It only knows the position to go to look for flowers, and it will only gather them if it touches a flower. And then the last thing we're going to do as part of this response signal is we're going to remove the signal it just processed from the signal list, so we don't process the same event again. And then down here we have our gather, deliver, panic, and below that is cower and fear, which comprise our finite state machine. And idle. Idle's blank because if the bee is idle, it doesn't do anything. Under gathering, to ensure that the bee doesn't break, if another bee gathers the flower that it's going to gather, or if the player picks the flower it's going to gather, if it gets to the position reported to it by the hive, then it will return to the hive to request a new flower position. And then once it gets to the hive, if it got a new flower location from the hive, it will go try to gather that. And then when it panics, it goes away from the player. It cowers in fear for X amount of time. And then this is slightly different from the scout. The scout always returns to its previous activity before, once it's done panicking. The worker bee, however, if the worker bee was idle before it panicked, rather than going back to being idle, it will go back to the hive to request a new flower, to see if new flower positions are available. And then if it doesn't get one from the hive, it will go back to being idle. If its previous activity was gathering or delivering, it will go back to either one of those. And then, just like the scouts, while the worker bee is panicking, it does not process any kind of sensory input. So before we start processing sensory input, we go ahead and we clear all of our sense events. Now up here, I mentioned that the hive broadcasts the panic notification, and it also broadcasts the player spotted notification to the soldiers. So the difference between broadcasting and narrowcasting is broadcasting, it sends a notification to all of the registered listeners, regardless of whether or not they need the notification or not. So that's what we're doing right here. The hive sends out, when the player presses the "oh crap" button, the hive sends out a panic notification to all of the bees that are registered with it. And then each individual bee is responsible for determining whether or not it needs to do anything. So in this case, if the bee is not panicking, it will panic. If it is panicking, it ignores the notification. And if we come over here to the scout bee, it does the exact same thing, as you can see there. And if we flip over here to the soldier bee, it does the exact same thing. So that's the difference between broadcasting and narrowcasting. Under the worker bee, this last function, new flower notification, this is where we're narrowcasting. The hive is responsible for determining which listeners need the event and only notifying them. So the hive determines whether or not the bee needs the event, and if the bee does, it notifies the bee that new flower locations are available, and then the bee will respond to that notification. So the last thing, the last bit of code that we need to cover is the soldier bee. Soldier bee is a little bit simpler than the other two. Up here we're going to register listeners with the hive. And then right here, just like with the panic notification, if a soldier is already chasing the player, it doesn't need to respond to this player spotted notification. So if it's already chasing the player, it disregards this, and if it's not chasing the player, it will start to chase the player. So soldiers, they start off patrolling. Soldiers, they will patrol an area around the hive until they're notified by the hive that they need to chase the player, or until they detect the player. So that's what this function right here does. What we're going to do is we are going to initially select a random position to move to within a specified area, and then we're going to move to it. Once we get to that point, we are going to wait there for a pre-specified amount of time, and once that time is up, we are going to pick a new point to move to in the specified area, and then move to that. The soldier bees will do that. Sorry, I was looking at the wrong thing up here. The soldiers will do that repeatedly until they're either notified by the hive or they detect the player themselves. So, like the other two bees, if the soldier is not panicking, it is going to respond to sensory input right there. And this is a little bit different. We're still using the same order of precedence to select a signal. So touch first, then sound, and then sight. But we're not interested in any flower. We're not interested in any flower signals that are sent. So if the soldier sees a flower, it ignores it. If it sees the player, it responds to it. Right now, the player is the only entity in the game that sends off a sound signal, so we don't have to check to see if that's the player. And soldiers running into flowers are going to be so rare that we don't really need to run the check right here. For the most part, if the soldiers run into anything, it's going to be the player. We could go ahead and add in this second test to ensure that we're only pulling player touch signals, but they're going to be so rare that it doesn't really affect the way the AI functions. When we come down here to respond to signal, for the most part, it's not going to be responding to any signals, because most of the signals that the AI receives are going to be sight signals from flowers. If it when it does detect a signal that it needs to respond to, it's going to be touch. And right here, we just verify that it is the player. And if it's the player and it touches the player, the soldiers, they're going to kill the player. If it hears the player, it's going to move to where the position where the sound signal originated from, and it's going to start to chase the player. And the same thing with sight. If it sees the player, it's going to move to the position where the player was spotted, and it's going to chase the player. And then we come down here to this small portion of the finite state machine. And what this does is this ensures that you'll notice that we never update the player's position based on the actual player's position, where the AI is not omnipotent. Just because it detected the player doesn't mean that it always knows where the player is. It only responds to what it sees, hears, and feels. So if like I demonstrated earlier, if the player moves out of its line of sight and gets far enough away that it can't, that the soldier can't hear it anymore, the soldier will lose track of it. And if it gets to the position where the player was last detected, and enough time goes by, it will reset and go back to patrolling. And then the only time the soldier panics is when the player presses the oh crap button. And it does the same thing that the workers and scouts do. It goes to a location that's far away from the player. And when it gets there, it cowers in fear for a pre-specified amount of time. However, unlike the scouts and workers who go back to their previous activities, the soldier, when they're done panicking, they always go back to patrolling. And then the last thing that we do is we clear the signal list to prevent bottlenecks and performance loss. So, I hope that gave you guys a good idea of how to work with sense-driven AI and how to work with polling stations, event systems, and how to broadcast and narrowcast events. And if you have any questions, feel free to ask. Thanks for watching.